Good morning. Today is Sunday, and the fog is gone. A little bit better weather now. It's still very cold here on campus. However, I thought I would reach out to you and talk a little bit about the midterm one that's coming this next week on Tuesday. That's going to be our first midterm, and as I mentioned in class many times, our first midterm is always the most challenging one because of the sheer volume of calculations and the problems associated with buffers and things like that. We have assigned a few problems, and on the lecture on this coming Tuesday, I'm going to assign more problems, and they all are going to be part of the midterm one. As I mentioned since the beginning, the lecture on Thursday would not be included in the midterm 1-2, but rather that material is going to be covered in midterm 2. I hope you are taking advantage of this extended weekend and start your preparation for the midterm 1. As I mentioned many times since the welcome video and later on, that this is very important that you don't let the material accumulate, because it doesn't work well when we do things here in the 11th hour. This is a subject that requires your continuous engagement, and I hope that you are taking advantage of this extended weekend, with Monday being Martin Luther King Day. So I thought I would talk to you today, and always I like to take the opportunity to provide some examples and things like that. So let me share with you some problems from midterm 1. Same that I did with the previous live from campus. I want to share with you some of the, let's see here if I can share some of the examples. Okay, so this is from midterm 1 from last year, the same class last year. So let me place it here in a better position to write on the iPad directly, and tell you that I always mention that the first part of the exam is going to be always for you to read the instruction very carefully. That might be equal to this instruction here, might be a little bit different as well. So we are going to have a QR code that you have to scan before you do anything else to make sure that you are there, because you wanted to have your exam, you want to have also your attendance to match to each other. People has been asking on Piazza, and I already addressed that about the formula. There will be no formula. As we see here, what we get, and this is not going to be different, you get a data bank, okay? The data bank would contain information that's going to be required for the exam, and also information that may not be required. This is part of your exam. It's part of your ability to collect the information that you want. So every time you need, you go to this table here to find the information that you need to finish up and answer your questions. For example, let's address this question number 3 here. That was a question worth 5 points. And as I promised to you, the first midterm exam would have 2 questions that are going to be questions that you can use then as an exchange, a trading question for any question that you don't know in the exam, or we are not 100% sure that they work, but only for 5 points, okay? So if you didn't watch this video of that I mentioned initially about the research in America, maybe you wanted to take an opportunity, if you have time, to watch that and to get acquainted with the content of the video, because that will be questions related to that. Anyhow, so let's address this question number 3 here, that's worth 5 points, and say, write inside the box the name of the following compounds in decreasing order of acidic strength: aspirin, cocaine, and Adderall. Example, drug 1, drug B, drug C. Clearly, I want to say in between parents in here what we mean by decreasing order. So from the strongest to the weakest, not the other way around. So the 3 compounds that you are mentioning here in this part are aspirin. So we go there and look at the aspirin. Aspirin is here. The other compound that is talking here too is cocaine. So where's cocaine in here? So let me find cocaine. Okay, so that's in here. All right. And Adderall. So these three compounds that are there. So let's write it down. So we don't need to do that in the exam, but let's write it down here, the three compounds. Aspirin, Ka of aspirin was 3.16 10 to the power of negative 4. 3.16 10 to the power of negative 4. That was aspirin. Aspirin was like that. I just write it down. You don't need to do that in the exam. The second compound was cocaine. So let's write the Ka for cocaine, which was 2.5 10 to the power of negative 9. This is for cocaine. And finally, the last was for Adderall. So the Ka for Adderall was 7.9 10 to the power of negative 11. So this is for Adderall. Okay, so very common medicine. So the question is, what do I do here to put it in the decreasing order? So the decreasing order goes to the one that is strongest. We talk about Ka in class, Ka being the relationship between the species, like for example, a generic acid H plus and X minus divided by HX, right? So the larger the numerator and the smaller the denominator, so this thing is large and this thing is smaller, the larger is going to be the Ka. What does it mean to have a very large numerator here? It means that lots of species are dissociated, right? So that means that they are strong. We gave an example in class of HCl being so strong that it's infinity for the Ka, right? So keep that in mind. So the larger the Ka, the stronger the acid. So what's the largest Ka of these three here? Of course, it's aspirin. It's Ka 10 to minus 4. So aspirin would be the first one that we would put here. Aspirin. Larger. Then what's the second one? Between cocaine and Adderall, cocaine has a stronger acidity because it's 10 to minus 9. So cocaine. And finally, the last one would be Adderall. All right? So that's very simple question, and it's not even asking you to calculate the pKa or anything. If it was asking you to calculate the pKa or something, then we will just get the minus log of these numbers and we get the pKa. Okay? So let's move to another one. The problem number 9 also is another interesting problem here. And let's see what we have. Part A and the part B, two parts for this problem, okay? In part A, they say, you prepare two 0.01 molar solution, one of acetic acid, abbreviate HAC, and another one of hydrochloric acid, HCl. First, calculate and compare the pH of the two solutions. If they are different, explain why. Okay, so one is a strong acid, right? One is strong acid, HCl. So in case of HCl, it's hard to write here on the streets on the iPad, 0.01 molar. This would be very simple because we know that this acid is completely dissociated, so the concentration of H plus is equal to the concentration of the acid, which is 0.01 molar. Therefore, the pH would be minus log of the concentration of 0.01 or 10 to minus 2, if you will. So the pH is 2. We did this in class, right? Exactly the same one. And now for the other one is HAC. HAC. Again, apology for the handwriting because I'm trying to do this thing here on campus, and then it's not very easy to stabilize and do right. Okay, so that's going to be something like that. As you know, what we do for this kind of problems when there's a weak acid, we take the concentration initially 0.01 and we subtract a certain amount that's going to be dissociated, and the same amount that dissociated generates H plus and AC minus. So that way we are going to find X. When we find the X, we know the concentration of protons, and we know the concentration of protons, we know the pH, right? So let's do that. For this acid here, we talk about acetic acid. It doesn't say, and my problems never say what you need directly in the problem. The constants are going to be there. You have to go back. Yes, you have to go back and find out what's the Ka for acetic acid, okay? So acetic acid here on the first one, 1.8 10 to the power of negative 5, all right? So we go back there and you say, okay, now that the Ka for this acid is 1.8 10 to the power of negative 5. So therefore, I know also that the Ka here equals x times x divided by 0.01 minus x, or equal 1.8 10 to minus 5, correct? Then in our class we already discussed that, and you have to trust me that this x is so small that we are going to neglect it, and we are going to say x squared equals 1.8 10 to the power of negative 5 times 0.01 or 10 to minus 2. So this letter here is really messy, so let me clear up that. All right, 1.8, better now. Not perfect yet. 1.8 10 to the power of negative 7. This is x squared. What I want is x, so I'm going to say x equal the square root of that number there. Where's my calculator here? So that's going to be 1.8 exponential negative 7, and take the square root. For that, I got x equal 0.00042. But always that I do this thing, please check it by yourself, okay? Don't trust exactly the calculator here, because I may make a mistake or something. So the pH equals minus log of the concentration of the H plus. We already said that the H plus is the concentration of X is the concentration of H plus, right? So 0.00030, right? 42. And I already had that number here in the calculator, just to take the log of that, and I got 3.37. And then the question is, well, are they different? And of course they are different. And why they are different? Because here, in all protons were dissociated. So all the protons were available. Very high concentration of protons, low pH. Here, not all protons were available because this is a weak acid. So only a part of it was made available and it contributes to the pH of the solution. Therefore, as the pH is a little bit higher than that. So the question is, if they are different, explain why. Because this is a weak acid and the other one is a strong acid. That's all. Just need to say that. That would suffice to get the full credit for this party A of the problem. It's getting a little bit cold in here. So let's move to the party B. Party B is that if you add 200 milliliters of a 0.1 molar solution of KOH to each solution above, 200 milliliters of HAC and 200 milliliters of HCl, what would be the result pH values for each solution? If they are not the same, explain why. So, in this question here, we are going to see that we have, let's calculate first the number of moles that we have, okay? We have 200 milliliters of HAC and 200 milliliters of HCl. So let's start with HCl. The number of moles of HCl that we have equals the molarity, right, which is 0.01, yeah, from the problem before. The molarity was 0.01, right? So in the here we have been told that there's 200 milliliters. So 0.01 times 0.2, that's equal 0.002 moles of HCl, 2 moles of HCl. And what about HAC? It's going to be the same calculation, so I'm not going to repeat that because the concentration is the same, the volume is the same. The number of moles of HAC is also going to be 0.002 mole. All right. Now, we are going to add KOH. We are going to add 200 milliliters of a 0.1 molar solution of KOH. So how many moles of KOH are you going to be adding? Number of moles of KOH that we're going to add is going to be equal to the molarity, which is 0.1, times the volume, which is 0.2, because it's 200 milliliters, right? 200 milliliters. So therefore, this is going to be equals 0.02 mole of KOH. Then, now the question is what we do. We subtract what we do. Look at that. We have we are at 0.002 moles of KOH, and we only have 0.002, 10 times less of HCl. So all the HCl is going to be disappearing, going to be neutralized, okay? And the only thing left is going to be KOH. So in that case, the prevailing species now is KOH, not HCl anymore. If you add less KOH than HCl, HCl is the prevailing species. But you did the opposite. We add more KOH than we have of acetic acid. So all acetic acid, or hydrochloric acid in this case, all of them have been consumed. So the only thing left is KOH. So now we have to calculate the number of moles of KOH final. This is going to be a basic solution, alkaline solution, because I had 0.02 and I subtract 0.002, which is going to give me 0.018 mole of KOH, right? And the volume of this KOH is no longer 200. The volume of this KOH is going to be 200 that we had added KOH, and 200 of the solution of HCl. So the volume is 400 milliliters, or 0.4 liter, right? 0.4 liter. So what's then the molarity of KOH? The molarity of the solution is going to be 0.018 divided by 0.4. Number of moles divided by the volume. Let me see what we get with this thing here. 0.018 divided by 0.4 equals 0.045. 0.045 mole. That's the concentration of KOH. So if the concentration of KOH is such, now look at that. This is KOH. What's KOH going to give? Hydroxide, right? So you can say that the concentration of hydroxide equals 0.045. Then the pOH, not the pH, pOH is going to be minus log of 0.045. So what we get with that? We get 1.35 approximately. So pOH equals 1.35. Are you asking the pOH? No, we are asking the pH. And the pH is going to be 14 minus 1.35. 135. Which is going to give me 1265, correct? 1265. Okay? So, are they same? Are they same? Yes, because what happened is that regardless of it being acetic acid or being hydrochloric acid, we are going to put excess of KOH. So we are going to destroy them. So in the case, if you do the same calculation, it's going to be exactly the same for HAC. Okay? Because we have excess of KOH. That's a very simple problem. You just have to think a little bit there to get out of the routine that we did in class, right? But it's very similar to what we did in class, including this class that it just passed in our case here. All right? So that would be how many points there? That would be 15 points in the exam. A very simple problem with 15 points, worth 15 points. Let's walk in number 10. I think that's the last one that I have to address for you today in this brief live from campus. If you prepare a buffer with 0.25 molar of 3-hydroxymethylammonium methane, also known as trees, and 0.25 molar of trees hydrochloride, what will be the result in pH? This looks like intimidate, but this is a very simple one. This is a trees called trees H+. You see the acid in here, the trees H+. That's this species here with the hydrochloride. It's called trees H+, and this is in equilibrium with trees plus H. This is a buffer, okay? And we prepared that buffer. When we prepare the buffer, we are going to use the Henderson-Hausberg equation. In the Henderson-Hausberg equation, I'm going to refresh here. That's pH equals pKa plus log of the concentration of the conjugate base, in this case here is trees, divided by the concentration of the acid, that in this case here is trees H+. Right? So that's a very simple problem, because I have the concentration of trees, I have the concentration of trees H+, that was given here, 0.25, very simple to make it life easier. Now, the question is, what we need for this? I needed the pKa. Where do I find the pKas? For pKas, I have to go back to the table and find the Ka, because I don't give pKa, I give Kas, right? So, okay, right there in front of us, 7.9 10 to negative 9. All right, so that would go to find this pKa, the Ka there. So the Ka for this reaction is, again, 7.9 10 to the power of negative 9. All right, from here, I can take the pKa, which is a very simple, minus log of 7.9 10 to the power of negative 9. All right, so let's see what we get from this. Again, 7.9 exponential negative 9. Take the log of this thing, 8.1. The pKa equals 8.1. Okay? Now, I go and plug in the table, and then I plug in the information that I have. pH is going to be equal 8.1 plus log of the concentration of trees. What's the concentration of trees? It says here 0.25. And what's the concentration of trees plus? Trees hydrochloride is the same thing, okay? Same name, is 0.25. So this is going to be 1, log of 1 is 0, so the pH 8.1. As simple as it could be, the pH is 8.1, okay? So that's a very simple calculation, and that's how we go about doing these buffer problems, and there will be more, but I just wanted to go back here and conclude this video, this live presentation that's getting really cold, although it's a much nicer weather than it was yesterday. So if you have questions, please post them on Piazza. Cecilia is going to be monitor the Piazza, and also I'm going to be looking at that from time to time. Yesterday we have a little bit glitch that the Piazza disappeared from campus, but late in the night it went back, and I was able to reply to one of the questions posed by one of the students. Feel free to send your questions. If the questions are, I ask that you first check if there is any question there, so they don't need to repeat the same question, because the reply may already be there available to you. If not, feel free to ask those questions. We are going to have lots of opportunities. So material on Tuesday is very, very important. That's why I posted the lecture in advance, well in advance, so that you can have a look. I also posted the solution for those two items that we have discussed in class, the titration, when we added 200 milliliters, when we had 300 milliliters. And then we go from there. We're going to recap this information at the beginning of the lecture on Tuesday. And from there, we're going to start to describe new information, new material that we might be prepared for your exam. Then on Thursday, we are going to get new material, but we're not going to be able to do review. But there is an office hour. And speaking of office hours, I tried last time to be an asynchronous office hour. Didn't work very well. I didn't see many students watching the video, so it might not be worth the extra time and exercise to do that. So therefore, I'm going to be planning to do the conventional office hour in the office as shown in the syllabus and the exact location here at the South, but the room number, I think it's 2089, is there, and the time is 3 o'clock to 4 on Wednesday. That's very important because that's the last office hours. Cecilia also has office hours, 2 office hours this coming week. Actually 1, but you know, if you needed it, we can always do something more, but we needed to see what's the interest of the students and how much feedback we are get from them in terms of the need. We don't want it to overdo that if it's not needed. Thank you very much for watching. I hope you success, and we are rooting for you in midterm 1. Thank you for watching.